Okay, so I will tell you what it is all about. So see, usually machine learning initially will start with like what is machine learning, what are the algorithmic types in machine learning. Like usually
Okay.
machine learning has two different fields. One is supervised machine learning and unsupervised machine learning. So
Hmm.
what are those terminologies? What are those areas basically and the applications of machine learning? So there I have just covered the short examples or short applications which you can develop maybe in few days or in just a short time. So those applications we will be seeing. So this is just 1 hour session, the introduction session about machine
Okay.
learning. Then in machine learning, as I told you, there are various fields. Like one
Hmm.
field is regression. Then
Hmm.
another field is, classification. So in classification, that's called supervised learning also. Okay. Then another
Okay.
field is
Hmm.
clustering field. That is unsupervised learning. That there, usually you have clustering and all. Now, the fourth field is there where you have some probabilistic classifier, the classifiers which work on probability. Like, what is the probability that this image will have cat or this image will have dog? So, something like
Okay.
that. Something like that. So, these are the four areas. So, okay, after this introduction session, I have kept two session for just 2 hours a practice for linear algebra in Python. So
Okay. Hmm.
just to introduce Python and what are the things which you can do in Python, like and what are these libraries NumPy, SciPy, Matplotlib. Scikit-learn is the very famous library in Python for machine learning. So whatever models you have to use, you can just import this library and you can use the models from this library. So and how do you manipulate array, perform some operations on arrays in a vectorized way? Those things we will be seeing in these two sessions. Once these introductory and session about machine learning and introductory session about Python gets over, we will start with the machine learning models actually. So our first model, linear regression. So we will cover
Okay.
this linear regression in detail. Then we will see. So basically, in linear regression, we will be seeing linear regression with one variable, linear regression with multiple variable. We will
Hmm.
also be seeing polynomial regression, and then okay, these are some useful things which you must know, which one must know while doing regression. And now,
Okay.
after that, in session 10 and 11, we will be seeing how you can evaluate your model. I mean, say, suppose you created a system to detect whether the voice is male or a female. The spoken voice is male or a female. So, that particular case, how can you evaluate your system? Basically, how much accuracy you got, how much error you got. So those things you have to evaluate it, right? So that there are some terms, confusion matrix, true positive, true negative, false positive, false negative. Through that you will, evaluate. Recall versus precision is again a metric for skewed classes. All these things I have covered, I will be covering in detail. So these are basically the evaluation metric that how can you evaluate your model and how can you test your system basically. So I mean, these two sessions are not some model. This is just an advice and or the metrics which you have to use in machine learning. So in linear after linear regression, we will come to a classification technique which is called as again logistic regression. So here this is the second model logistic regression which we will be covering, and we have lot of Python practice Python examples. If you see, uh, we will be doing in between we will be doing lot of hands-on Python. So two, three examples in linear regression, then one example in logistic regression. Then in supervised learning, we will have five models: support vector machine, boosting, random forest, decision tree, and KNN. So all these five models, which are the famous models of machine learning, I have kept here in supervised learning, which we will be covering. So this is also again a supervised group of set of models which follow supervised pattern, supervised way approach. And now in unsupervised learning, we will be seeing two techniques. One is K-means clustering. It's a very famous clustering technique. Clustering techniques are basically used to find groups among the data. Okay. Then comes dimensionality reduction in unsupervised learning. Dimensionality reduction is again another technique which is done with an unsupervised approach. Okay, so finally we will be seeing some probabilistic classifier which classifies the data based on probabilities. Okay, so these two classifiers we will be seeing, naive Bayes and Gaussian mixture model. And these days, just maybe you can say after 2006-7 or 2008, these neural networks had picked up a lot. So these have become, state-of-the-art models, which are very much used in machine learning. But yeah, neural network is quite complex thing, and you might have heard of these words, deep learning and all. So this neural network is a complex and advanced thing, which we will have an introduction of in this sessions, in this course. We will have an introduction of neural network, how neural network works, what are the hyperparameters, and we will see some practical Python examples also. Okay.
Okay. Yeah. Okay.
So this is the detailed 50 hours session, uh, through which I will be covering, and maybe through the recorded videos or whatever. So majorly if you see, you can divide your this whole course into three parts. One is regression, then one is
Mm.
supervised classification, supervised classification, right? Then you have um, unsupervised classification, uh, unsupervised classification. Then you have probabilistic model,
Mm.
probabilistic models. So majorly these things are there, and then one more thing is which I have kept totally separate is neural network. Neural network is again a whole field altogether, but we will be covering the basic stuff. I mean basic in neural network. So in regression we have linear regression with multiple variable, and polynomial regression. These are the three uh, models which we will be covering. In supervised classification models, we will be covering logistic regression, which was our second model, if you remember in the course structure. Then after this, one is logistic regression, and then another is KNN, K nearest neighbor. Then we have decision trees, random forest, gradient boosting trees, and then finally SVM. So supervised learning. I mean, most of the people, most of the applications are majorly built in supervised learning. So that is why supervised learning is basically it's a classification technique. So that it's very popular actually. Okay, so that's
Okay.
they have come up with lot of models in supervised. In unsupervised, mainly it is clustering. So one is clustering. Again, there are various algorithms for clustering also. This is a very popular one. So this we will be covering.
Hmm.
K means clustering, and then there is something called as dimensionality reduction techniques. So in this particular algorithm is very famous, PCA, principal component analysis. So this we will be covering. In probabilistic models, we will be covering naive Bayes classifier. It is actually supervised learning only, but it is based on probabilities. So I have kept it as a separate model. And then probabilistic model, there is something called as GMM, Gaussian mixture model, which is again a clustering technique, a unsupervised classifier only, but it also works on probabilities. So I have kept it separately. Now the neural network is again a very famous model, but now it has picked up a lot of pace, and it's a complex model. It is basically based on our brain. The motivation of neural network has come from how the neurons are there in our brain, how the neurons are arranged in our brain. So similarly, this neural network also works. So neural network is again a whole field. I mean, if you do some course on neural network, it will be again some 30-40 hours, and you will learn a lot. You have to learn a lot. But we will be doing it the basic and some example on neural network how you can move on. I mean, get a hands on that. But in total, we will be covering all these models session by session. And as yeah, and initially, in this course structure, I have included the introductory part, also the linear algebra um, part with Python. I mean the Python introduction. Actually, I will tell you in this whole machine learning course, or any this machine learning subject, basically, it requires a little knowledge about mathematics, because these courses are based on mathematical foundations only. So, we have seen in our school days or whatever, like we used to study what is the equation of line, right? What is a polynomial equation? What, how a curve? What is the equation of the curves? So, what was differentiation? What was partial differentiation? So those things. What is a convex function? So lot of mathematics will come into picture, but that's not.
Okay.
But yeah, a lot of mathematics will come in picture. But two things are there. One thing, that is why we are keeping this training. I will be explaining you the mathematics in detail. I mean, as far as possible, I will go. But yeah, sometimes some things are beyond the scope of the course. So those things I will leave. But yeah, definitely this training is all about understanding the models to the depth which we can go within the time limits, right? So I will be
Hmm.
explaining you all these models from mathematical point of view also. The second point is the good news is, which is the second point, that to implement or to build a machine learning model, to build a machine learning application, any application you say, which your client have asked to do. So to build a machine learning application, you do not need to understand and code the whole mathematics. You do not need to write the codes for mathematics.
Yeah. Yes.
So
Yes.
basically, you can easily import the libraries like scikit-learn is there. There are a lot of libraries, lots and lots of libraries people have made in Python, and those
Hmm.
libraries, and those are very efficient implementation, I must say. So you can use those library very well, and you can build your application. So you don't have to code all these mathematics on your own. So that's the good thing. And but again, you should have a good understanding of the mathematics parts also, so that you can apply them, because the application, the logic will come from that part only. So that's how this whole course has been structured, where you will see that after initial some introductory session, uh, You see, all the mathematics has been covered, and then practice Python. I mean, Python examples, I have put lot of Python examples I have tried to put. Uh, so, like this one. Hmm. Like in supervised learning with every model, like KNN, there is a Python example. With decision tree, this is a Python example, iris dataset. With random forest, wine dataset, Python example. Boosting, again Python example. Support vector machine, again a Python practical. Two, three Python practicals are there. So I will be showing you a lot of codes to show how these models work actually. That's what I mean to tell. Like in K-means clustering technique, we will have a uh, short project on K-means. I mean image compression. How can you compress the size of an image with K-means clustering? Okay, we will also see a IS dataset visualization example with PCA. So again, in probabilistic model, again two short projects are there. So it's a very detailed and a long course which we will be covering in 50 hours maybe, or whatever it is. Maybe it will take some more time also. Maybe it can go 5 hours more, because like currently I am providing training the same course to two guys. So that's what I feel like. Even this 50 hours I have made, but it will take maybe 55 hours or something. But yeah, this will give you a whole idea. And after this course, if you are following it very, like I will be providing you the recordings and the things. If you will follow the recording and if you will follow the Python examples, so definitely you will be, you will get a hands-on at the end of the course, where you can build applications on your own. Although in this session, in this course also, there are two, three applications which has been included, which you will find interesting. But yeah, some complex and big applications also you can then try making it. Once you are good at building some applications in using these machine learning model, you can then definitely apply or switch your field or your job. So but anyway, like this machine learning, after this machine learning course also, you will have to work for maybe 3-4 months to get some experience, to get some more hands on, because these days, the companies and these IT industry, they require machine learning people a lot, but what they look for is little bit of experience. So if you have experience, if you do a lot of coding in this, maybe for 5-6 months, then definitely you can maybe apply for some machine learning field or machine learning jobs. This is one thing. Another thing is, I just wanted to I just wanted to know that how much of, I mean, how you have just heard about this area, or you know this area, like what is machine learning, what is AI?
Yeah, machine learning language. I helped with one of my friend
Okay, yeah, that
how,
yeah.
how
So
to use this one.
okay, okay. So that's where only you have heard about machine learning, right?
Yeah, so correct, correct. Yes,
Yeah.
yes, yes.
Okay. Okay. So not a problem. So what I will do is I will introduce this machine learning a little bit. What is this all about actually? So that you have an idea of what machine learning is all about. Because yeah, I mean it's not a tool, or it is not a simple, it's not a language, or it's not a tool which you have to just learn, and maybe you can it has lot of logics, it has a lot of intelligence. So basically, artificial intelligence, you might have heard a lot number of times. AI, this AI, that AI, Google is doing AI, IBM is doing AI. All these big giants like Facebook, Google, Microsoft, they are doing a lot of machine learning, lot of AI these days. So you might have heard of AI, but yeah, machine learning is a field of that which creates intelligence, which gets extracts intelligence from the data. So okay, I will explain you this machine learning little bit, uh, introductory part, what it is and what it is all about. So later on, maybe after that, once you have idea, you can read about it more, and then definitely we can go with the training part. Okay.
Okay, okay. Thank you.
Okay. Okay, so let's just start with the machine learning, this briefing introduction. So machine learning is basically used to extract intelligence from the data. I will give you numerous examples, maybe 5 to 10 examples I will give you, where machine learning has been used. Like
Hmm.
uh, like one example is handwritten digit recognition. Okay, so in US or in Indian Post services, you might have seen earlier, or these days also, you have to write PIN code here, right? On
Yes, yes.
on the letter, or whatever
Hmm.
registry or whatever courier you do, you have a PIN code kind of stuff, right? Which in boxes
Right.
you have to write PIN code, that okay, 530019, something like this, right? Now,
Yeah,
I
yeah.
will tell you, yeah. So now there are, say, thousands of letters coming into the service center, Indian Post Service Center, whatever it is. So,
Hmm.
and your work is to identify which letters are from for which pin codes. So basically, you have to categorize the letters depending upon the area. These will go to Kolkata, these will go to Delhi, these letters will go to Bombay, like that. Now,
Okay.
instead of doing manually, so earlier what was happening? Earlier, some person manually will be doing this thing. I mean, some person will sit and segregate all these letters and all this postcard, and then send it to different places. But
Okay.
in US, I will tell you, in US, 1982, in 1980s, it's a way back thing, like now 40 years back thing, maybe
Hmm.
35 years back thing. In US, first time you applied machine learning to recognize the digits in these boxes. So
Okay.
they built an application. They built an application where they used to read these boxes,
Okay.
and then this is the image. This is an image. Okay, this is an image problem.
Hmm.
Image processing. This is an image processing problem where they will take the image of this whole box, and then they will take each box and they will try to predict what is the digit inside the box. Okay,
Okay.
so this kind of thing you can do from image. You can know what is the number written over there, and once they get all the number, just through software, just through a system they built, they scanned all the documents automatically, and they scanned and they separated all the documents they used to separate automatically. So machine learning is used a lot in automation. So this is one example. This was just one example. I will give you another example, numerous example I can give you. Like suppose there is a text. Suppose
Hmm.
there is a text like suppose the performance of Samsung is very good. Say any mobile you can take. So the performance of Moto G is very good. It has a lot of RAM and lot of memory. The camera is also good. Suppose these three lines are written. This is a review about a phone. Now,
Hmm.
for a particular phone, if you see the people, I mean, thousands of people write reviews, right? Now,
Yeah.
there is one thing where you have this star rating kind of thing, right? Like people will give them a star 3.5, 4.5, like that. But suppose you have a post, or you have a tweets, or you have a reviews which is coming, and you have lot of reviews, but there is no starring, and you have to find out whether the product was actually good or bad. This is a very famous problem called as sentiment analysis. What it is called?
Okay.
Sentiment analysis. So in this sentiment analysis problem, given a text or given a post on Facebook, or Twitter, a tweet, you have to tell whether the sentence has been written in a positive sentiment or a negative sentiment. So if I will write, Trump is horrible, and he is very bad, and some negative comments I am giving about, say, Donald Trump. So then in that particular text, it will say that it is written in negative sentiment. So this is kind of, work, machine learning can do. Detecting whether it is a male or a female from voice. Detecting who's the
Okay.
speaker in the speech, right? Like suppose, there is a bank called as Wells Fargo. I mean, you may have heard about it. uh, Wells Fargo, there is a bank. So there they have deployed a whole system. I mean, recently I was talking to some employer, some IT guy from that bank, uh, who was interested in this machine learning, and fortunately he told me that this system is there in their bank. So I will tell you what is the system. The system is, suppose it's a whole big building, right? Now suppose you need to order, say, 2 cup of coffee for your guests, right? Now
Okay.
you don't need to pick phone and dial some number, and then say wait for the other guy to pick up the call, and then you say that, hello, I want 2 cup of coffee. You don't need to do that.
Hmm.
Just that what you need to do is, you pick up the phone and just speak in that, 2 cup of coffee please, and just put the phone down. Now
Okay.
from your voice, 2 cup of coffee please, from your voice actually it will detect who is speaking. So suppose
Yeah.
they come to know, they came to know, okay, somebody is speaking. I mean, this guy says Suresh is speaking. Now
Okay.
they will also get from the database, they will take out where do you sit, which floor, which cabin, and that message, that voice will be sent to the coffee house guy, who will send you the coffee. So
And how it will reach, Abhijit?
how?
Because
Yeah,
we have people today 100,
yeah,
tomorrow 1,000 people.
yeah.
How the algorithm we can set that
So
mission
yeah,
with this?
so in machine learning, there is two part, actually, two phase. One is training and
Hmm.
one is testing. So what
Okay.
we do, on the historical data, on the previously known data, that is called as training
Hmm.
data. We train our system. Basically, that thing I was just coming to. Basically, in machine learning, what we do, from the previously known data, or previously, historical data which we train our system. We train our software, that you learn that this voice is of this guy, this voice is of
Hmm.
this guy. So like that, I will make my system learn that, so that, such that when the next time
Hmm.
the voice comes, it can easily identify who is the guy. Now, you are talking about the scalability. Like suppose initially
Ah.
you have 100 guys, people. Then now some other
Hmm.
employees also joined. So
Right. Right.
just have to enroll the voice there. I mean,
Oh, we need to add that
yes,
one
yes,
to
yes.
this.
In that software, you will get a privilege, or I mean, you will get an option to add the speaker. Okay. This problem is called, it is a very famous problem in speech processing. It is called as speaker identification.
Oh, okay. Okay.
Okay. So I will categorize this thing also. There are three major areas of machine learning. One
Okay.
is one is speech processing,
Mm.
where you speech analytics also it is called, where you try to find out what is the gender of the voice, what is the language being spoken. So right now I am speaking English. Can you take my voice and predict which language I am speaking? Like our human mind can easily perceive that you are speaking English right now. But can you just imagine a call center or any say a place where thousands and lakhs of calls are coming. Lakhs of
Mm.
calls are coming from all over the world in a customer care center, and you need to route all the languages to the specific linguist who can answer that call. Like a French guy,
Okay.
when a French guy will call, only the French linguist or the guy who knows French in the customer care, who he can only handle, right? He or she can only handle. So
Uh,
so this kind of routing you can also do if you place a language identification system in place.
okay.
So,
Okay.
so,
Mm.
so, so this is all an area of speech processing where you want to find
Mm.
a language, where you want to find who is the speaker, what is the gender. You also, if two speakers are speaking in the same audio, so can you separate out which speaker spoke when? Then there are a lot of things. Keyword spotting, like in your defense application, this keyword spotting is very much used. Where if on the call, I mean in the call tracing, if somebody is talking negative, like somebody is talking about terrorism or some attack at some, they are planning some attack. So those keywords it can catch and it can alarm you that okay, in this call these are the words which are spoken. So that is called
Okay.
keyword spotting. So like that there are a lot of application in speech processing. Then there is
Mm.
something called image processing. In image processing, as I told you, digit recognition, object
Mm.
recognition, basically. In
Okay.
image,
Mm.
what are the objects there? Like
Name
yeah, yeah,
like hand, face, neck.
yes,
These are
yes, yes. So if you see image processing, face recognition is another big application. Fingerprinting
mm.
recognition is again another application.
eyesight.
Yeah, iris detection is again a application. Lot of applications are there. In image, there are nowadays, in traffic lights, in traffic, what they have done in signal, traffic signal, where
Yeah.
there is traffic signal, they have kept a camera. So if your speed is more than 80 or say 60, whatever the speed limit is, it will just take a picture from the I mean from back side, and it will automatically, through image processing, it will mark down that area, your number plate it will detect, and it will read your number, car number.
Right. Right.
That
Yeah.
camera will do. I mean, this system is installed in Tamil Nadu or somewhere. Chennai, it has been installed somewhere. So
Oh, okay.
this is again a huge. This was again a huge research problem, where
Mm.
from the moving cars you have to take a still picture, and from that you have to detect the number plate first, and then the letters. I mean, what is the number of your vehicle, and through that you can just automatically generate some challan or some fine if there is a over speeding case.
Okay.
So those things with image, lot of things you can do. Again, satellite images. With satellite images, you want to know whether on border areas what is happening or those things. Whether they are placing some tanks or whether they are making some helipad or something like that in the border area. So those things in satellite images, there is a lot of machine learning used. So again, the third field is text analytics. Text
Okay.
analytics. Text analytics is natural language processing. It is also called as NLP. I mean, if you will read on internet, it is less known as text analytics, more known as NLP, natural language processing. So
Okay.
in NLP, given a text, what is the sentiment? say given an article, I gave you a raw 1,000 raw documents. Can you tell me in each document what is the thing which is talked about? What is the topic of the article? So that is called as topic extraction. Topic extraction
Okay.
from articles. Suppose I give you 1,000 articles and I told you that categorize these articles in politics, news, and all these categories. So can you do the document clustering thing? Can you categorize the articles in an unsupervised way? You don't know what are those 1,000 documents. You are just given 1,000 documents, just 1, 2, 3, 4, 5, 6 like that 1,000. You even don't know what is the name of those files. But still, can you say that okay, out of these 1,000, these 200 files are talking about politics. These 200 files are talking about sports. These 200 are talking about some medical issues or medical thing. So this kind of things are done in text analytics. I mean, these media houses, they used to publish lot of blogs and lot of articles daily. So in media houses,
Okay.
machine learning, NLP, text analytics is used a lot. A lot.
The videos are there, na, Abhijit?
What?
The videos is available, this reference data.
Yeah. For the recording, you are saying the recordings for the course.
Recording plus reference of these books. So some of the books are there, no?
Yes.
Material.
Yes, definitely. I will tell you the books, or I will tell you a lot of articles to follow. What are the links you can follow and how you can build these kinds of application. All these applications I am telling you, this whatever application I have told you right now, you can make in Python actually. And I have made it. This sentiment analysis, digit recognition, speaker
Mm.
identification, language identification was my actually MTech project. So speech processing is little bit complicated because of the signal processing. So if you have an electronics background, then that is very much useful. Like, what is your background?
Yeah, computer science statistics.
Okay, computer science strategy. So you have done BTech?
MSc computer science from Andhra University only, Visakhapatnam.
Okay, Vishakhapatnam only.
Visakhapatnam only.
Okay, great. So I am also staying in Vishakhapatnam only.
You applying the mission language there in industry, any factory?
Yeah, I basically work in a research organization. That is a
Uh-huh.
that is a central government research organization. So there I have this profile, research profile, where I have to do all
Oh,
this research related to machine learning and artificial intelligence. I have to build such software for some applications.
okay, that's
So
great, Ajit.
yeah. So I mean, last 4 or 5 years, I am working on these areas only, developing some
Hmm.
applications, and that's why I also provide training on this. So anyway, uh,
Okay, that's great.
yeah. So these are the applications which you can develop. Now I will talk about how you can develop this. What is machine learning actually? So machine learning
Hmm.
is about training
Okay.
system, testing system, huh?
Okay.
And in machine learning, the very important thing is data also.
Hmm.
So there are three things. First, you have to collect a data. You have to make a data set. So suppose you are going to make a digit recognition. So at least
Hmm.
you should have images of handwritten digit images should be there with you. So any examples you are going to do, like if you are going to make a software which can detect whether it is a male or a female from software. Okay. So
Right.
at least you have to collect some, say, five minutes of male and female audio in order to
Hmm.
build the model. So once you have
Okay.
got the data, you can
Hmm.
you can extract some features out of it, and then you can train your system, and finally on the trained system, whatever model you have trained, the I have told you like 12 to 13 models: linear regression, logistic regression, KNN, SVM, decision tree, random forest, gradient boosting, naive Bayes classifier, GMM, K-means. Lot of algorithms are there. So depending on those algorithm, any one of them you can take and you can train your system through it, and then you will test it. Okay.
Okay.
So in machine learning, the main thing is you should know for which application which kind of model will work. Like if you have a classification problem, then regression model will not work there, or clustering model will not work there. So for a classification problem, only the supervised model will work, and that too, in that supervised also there are a lot of models. So which model will work best? So when you will understand the mathematics behind it, when you will understand the all these models, after once this training will be over, you will understand all the working of all these models, and then you will be clear, and you know, given an application, you can tell which model to apply.
Yeah. That based on that we can apply. So how do you know this model is suitable?
Yeah, so based on that you can apply. So that is what we will see model by model. I
Yeah.
mean, each model we will see what that model does and where it is applied. Like whenever
Okay.
there is something about clustering, like uh,
Mm.
I will give you an example.
Okay.
Suppose your data is something like this. Okay,
Hmm.
this is one class A, and this is class B.
Okay.
Uh, Now, if this kind of data is there, you can use any binary classifier. Okay,
Hmm.
I'm just telling you, like, so you can use you can use here logistic regression,
Okay.
or you
Hmm.
can use the SVM here, support vector machine. You can use other algorithms also, but I'm just telling you, in this kind of data, you can just place a line, isn't it?
Okay.
Yes.
Classification.
Yeah, it's a classification problem. So basically, there were data points of class B and class A. Now, if a new data point comes, so suppose a new data point came here, which class it is?
Hmm.
It is of class
Is
B.
it big?
Yeah. Suppose again a new data came, say here, so it is which class? A. So all the points which will lie on this side of the line will be class A, and all the points which will lie on this side of this class A will be B. So this is a simple example of classification. But here, if you see, you knew that these data points are of class B, these data points are of class A. There can be a problem, I will tell you. Suppose you have been given data like this.
Hmm. Spots. Okay.
Now in this data, in these data, you do not know which is which class. Suppose these are
Hmm.
just these data points, each point represent a article, a news article,
Okay.
or a document. Now each, I mean, you do not know the label. See here, you know that this is cross, this is zero, circle, this is circle, this is cross. Here you don't know the classes, and
Hmm.
your boss or your client says that you have to categorize this data. You have to categorize this data,
Hmm.
and tell me what are the groups, which documents are similar.
Yeah. Okay.
So there are some clustering algorithm,
Uh-huh.
clustering algorithm which will find clusters. So it will find the cluster like this. Wherever it can
Okay.
find the groupings. See, this.
Hmm.
If I give it this clustering algorithm, if I give k equal to 4, which is a parameter actually, it will find four
Okay.
groups for me. Now, even though I do not know the data, even though I do not know the label of my data labels, still I am able to find the groups. So this is another kind of. So here you cannot apply a logistic regression. Here you cannot apply a plane or something like this. Here you have to apply the clustering algorithms. So for different, yeah. So for different kind of data, different models are there. Of course, sometimes in a supervised learning model, if you will see, you will have some more choices. So in that case, suppose you have 3 4 models which you can apply for a classification problem. So in that case, what people know, they will try with each model and see with which model actually the accuracy is coming good. I mean the model performance and the application is performing with which model. So that you will see. Okay. So and then whatever model is performing best, you will use that model. So there are different ways to find out which model was best. We will be covering all those things. Okay. So this is a typical example of how machine learning problems are classified. So I will quickly I will tell you about machine learning. See, this machine learning, this is a Tom Mitchell definition which he gave, that a computer program is said to learn. I mean, this is the definition of machine learning. So this definition was given long back. I mean, I don't know how much relevant it will be today, but yeah, this is a proper definition of machine learning, which actually machine learning is what machine learning is all about. So a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P. If its performance at task T as measured by P improves with experience E. So basically this is a little confounding statement. I mean, you will be confused by a lot of P's and T's. I will tell you what actually it means. It says that as your experience is increasing, your performance will also increase on some task. So basically it is like our human mind. Like when we are child, we used to have we have never seen a car or any vehicle, right? So first time we are told that, see, this is a car, see, this is a car, that is a car. So even when you have just seen maybe 4 5 cars, next time even if some other car comes, suppose you have seen Honda City, i10, i20, and these cars you have seen, maybe Swift or something. But even after seeing 4 5 cars, even if you see another car, say Audi or some other car, say Bolero, still you will be able to tell that this is a car. I mean, your mind will actually learn that this kind of thing is a car. So this is also going to be a car. So basically what I am telling you, with experience, our mind learns things and the performance will increase. So same thing applies to machine learning also. If you provide a machine learning system good data, if you have a good previously known historical data, that is why machine learning data is very important, very important. So if you, as you have more and more data you will provide to your system, the performance will increase. Suppose I have to make a cat versus dog classifier. So given an image, I have to make a cat versus dog classifier where I have to identify whether the image is of cat or a dog. Okay.
Right.
Now this is a supervised problem. I have 500 images of cat and I have 500 images of dog, and I have to classify. I have to train my system such that afterwards when a new data will come, it will classify whether it is a cat or a dog. So now this training of system is happening on these 500 images of cat and 500 images of dog, right? Now this, according to this definition, if you increase the data, if you increase the experience, suppose instead of 500 cat and dog, you give it 1000 cat and
Hmm.
1000 dog images.
Okay.
So if you
It
increase the
increases.
experience, your model will be trained well now. Your model, the trained model will be even good, and the performance will improve.
Right, right.
So
Okay.
as you give more and more data, your performance is going to increase. I mean, that's
Hmm.
what Tom Michel said. It is true, but it's not like if you will go on increasing your data to lakhs on lakhs, your model accuracy will become 100%. It's not like that. After increasing to a certain limit, the accuracy, the performance of your model will saturate. Like you start from your data set, so you will get some accuracy, some performance measure, right? Then you increase the
Hmm.
training, you increase the experience, then also the performance will increase, but it will keep
Hmm.
increasing as you are augmenting the training data, but after some time it will saturate. I mean,
Okay.
suppose you are able to identify that this is a car. So
Hmm.
as you learn through ages, I mean from childhood you learn that okay, this is car, this is truck, this is bus. So you learn, but after a point there is no meaning of learning, right? If you are not able to identify some car which is very far from you, or which is not visible clearly, that even if
Hmm.
you do so much of training, and no matter how many cars you see, those cars which are not visible or which are very far, that you can, so 100% accuracy, it's very hard to achieve. But yeah, this particular definition is true to a very good extent. This
Okay.
was given by Tom Michel. Tom Michel is a renowned guy in machine learning world. Okay, now this is again a very important, Venn diagram which I have made. This Venn diagram, if you will see, this is all these fields I have combined together, because people, I have talked to people, people will always have this confusion. What is data
Right.
science? What is data mining? What is big data? What is deep learning, machine learning? Where this all
Art-
these areas fit into?
Yeah, robotic process and these
Where is
things.
robotics, robotics automation, and where is all those things? So that is why I have made this Venn diagram. So I will just
Okay.
explain this part. uh, Artificial intelligence is a bigger term and the conventional term which is there from 60 years maybe. So
Oh.
from long back, from 1940s, 1950s, these people, the mathematicians, and these people have come up with this AI term. I mean, everybody, at least, even a lot of people will not know this machine learning term, but they will definitely know this AI term, artificial intelligence, AI. So this is a very
Okay.
popular field. But AI was not actually successful in building a lot of applications. The applications, like the applications which I talked about, people have done a lot of AI, but these kinds of training your system and getting the intelligence out of data, so that you can
Hmm.
use that intelligence for the future data on the unseen data, those kind of
Okay.
systems, artificial intelligence was not able to build. I will tell you why.
Hmm.
I will tell you why.
Okay.
Because these machine learning system and these machine learning algorithm requires training, which requires a good hardware and a sufficient time also. So earlier, back
Okay.
in 16, 17, 80s, at that time, we didn't have, a larger processor, a larger data. I mean, if you remember, maybe in 1995 or 96, even in 2000, these P3, P5 computers were there. So
Hmm.
this Intel P3, P5 computers were there, and those computers were like very slow. If you see today's, how the today's systems have been evolved with one laptop having 8 GB RAM, and like earlier it was used to be 256 MB RAM, isn't it?
Right, right.
128 MB RAM. So if you even if you think about such kind of application, say face
Okay.
recognition or say digit recognition. Now, how are you going to train your model? Your images itself, your image data is itself of 1 GB. Now, how will you,
Okay.
how will you, push those 1 GB data? You will extract the features, and how will you take that whole data into RAM? It's not possible. You will have to buy a very costly, system at that time. Where,
Right. Right. Yeah.
so that is why for common people, or you say common engineers, common researchers, it was not affordable to do these things. So as our computational power has grown up, where you can put 8 GB now directly in your RAM, so those things has come up very well now, and that is why machine learning. I mean, these kinds of systems where you can train your system and test your system and you can build these application. These kind of system has become very popular. So
Okay.
machine learning is not considered different from AI. Machine learning is actually a field of AI which has evolved after 1990 mostly. Mostly it has evolved after 1990s, um, as our computational power has increased. I will give you
Let's say,
a, yeah,
Abhijit, I have one query
yeah,
because even I am not comfortable much. People are talking artificial intelligence.
yeah.
What is exactly will do artificial intelligence? What is the
Yeah. So artificial intelligence, so that's what I'm saying. Machine learning is a subfield of artificial intelligence only. Whatever you do in
okay,
machine learning, you can consider it as AI only. In fact, if you will ask me, machine learning is the new AI.
right, right.
Like machine learning has covered almost all the problems which
Hmm.
AI can do. So basically, machine learning has overpowered. You see, if you go back 10 years back, just 10
Hmm.
years back, people were not, I mean, maybe before 2000, there was nothing like machine learning. Even in the industry, you might not have heard about this name machine learning before 2002 or before 2004.
Yeah, recently it came back.
Recently, the development has happened, and all these applications which we are able to build with machine learning systems. So this is a kind
Hmm.
of artificial intelligence only. See, artificial intelligence is all about, I will tell you what is artificial intelligence. Artificial
Okay,
intelligence is simply what we human can do naturally, that you have to do through software. You have to do through some artificial thing.
okay. Hmm.
Whatever you can do, whatever we human can do, we human can perceive things. Same thing we
Okay,
are trying to mimic through software or hardware. Like
okay, okay.
like
Hmm.
this robotics. If you see this robotics automation,
Hmm.
in lots of manufacturing industries and lots of not in IT industry, but yeah, in manufacturing industry, if you see lots of robots and manipulators, two arm manipulators, stimulators. I mean, there are a lot of robots which does things for you, right? So
Yeah, yeah. Right, correct.
this robotics is a very good example of artificial intelligence, where it can do certain things for you. Now in robotics
Hmm.
also, if you see, now you might have heard of this autonomous vehicle driving, car driving.
Automatic, without driver.
Without driver, your car is driving. So basically,
Right.
these things are built with machine learning only, or you can say
Okay. Okay.
artificial intelligence. So
Hmm.
artificial intelligence is a big word. Artificial intelligence is a conventional superset word, I would say. Machine learning has become popular in recently, maybe last 10 years. But right now, whatever problems are there, people are going with machine learning only. So artificial intelligence has just faded now, or you can say not faded, but it has, the name has been changed to machine learning. Now everyone is talking about machine learning, machine learning. Basically, it's AI only, artificial intelligence only.
Okay. Okay. Got it.
And
Okay.
this deep learning also you will hear maybe a lot of time. Deep
Yeah.
learning is a field of, again, a subfield of machine learning. This deep learning is based on neural network models that I showed you.
This is it's IoT. It's also IoT.
No, IoT is different thing. IoT is Internet of Things. In
Hmm.
IoT is like how you can combine lot of devices together. I will tell you about IoT. Uh,
Hmm.
IoT is something like, suppose right now what is happening? Right now only your computer can communicate, right?
Right. Right.
Your system through internet you are communicating, right? Now,
Hmm.
the IoT is about that, can I connect all the devices, all the chips, whatever machines I am using in home or anywhere, in your office, anywhere. So can I
Hmm.
connect all these devices so that I can communicate with it, even I don't have to go and manually do things. Like suppose I am sitting in this room and I want to
Okay.
say turn on the AC of uh, some other room.
Hmm.
Or suppose I found that my AC for some other room is on. I have to off it, and I don't want to get on off my bed and then go and manually do that. So what I will do, all these
Hmm.
devices, these IoT devices comes with some special hardware, special chips.
Oh,
So
okay.
I can connect through these devices, and from my laptop I can shut down that AC.
Oh, okay. Without manual interaction.
Yeah, without manual interaction, basically it's all about, that is why the name is IoT, Internet of Things.
And watch also. Let's say watch Facebook.
Yes.
We can see.
Yes, yes,
Okay.
yes. Smart watches are there. So nowadays, see, whatever conventional TV, fridge, or washing machine, or whatever conventional items were there, that cannot be connected through IoT. That is not IoT. That you cannot do IoT. IoT you can do
Oh,
when these devices, when these machines comes with a special hardware where it can connect through your mobile phone. It can connect through your laptop. So
social media.
yeah, so just on the laptop, you will get application, and that
Hmm.
application you will open, and there will be refrigerator, fridge, AC. So you can increase and decrease the temperature of your AC. You can increase and decrease the temperature of your maybe refrigerator from your laptop just on sitting on bed. So this is just an basic idea I am giving about the IoT. IoT will again be a huge field, but just an example I am giving you what IoT is all about. But IoT is more about electronics and communication. It is less about
Hmm.
statistics and machine learning. It's not AI. Okay.
Okay.
It can
Got it.
also be combined with AI, but yeah. So, so that's what I told you. Artificial intelligence is basically mimicking, artificially creating the intelligence that we human have. But unfortunately, over the 30, 40 years, artificial
Hmm.
intelligence was not that advanced, and it has not come to industry that well. But now with advancement in machine learning, lot of lot of popularization, and lot of buzz is there in the industry, and it has come to, I mean, lot of real time system has also been built with machine learning systems.
Okay. Okay.
So
Got
that
it.
is, and deep learning is basically based on neural networks. So the 12, 13 models I told you, I also told you deep learning. So deep learning is basically based on neural networks. Now, what is big data? Big data
Hmm.
has an overlap with machine learning also. Big data,
One minute. One minute.
yeah,
One minute. Sorry. A neural network means complicated system. Huh?
I will tell you what is neural network. Neural network is something like this. See, in our brain, there are neurons. You know neurons?
Never. Ah.
In our brain, there are neurons. In fact, I
Okay.
will show you the slide. Um,
Hmm. Okay.
our neuron, how our neuron looks like. See, this is the representation of a neuron, brain neuron.
Oh, okay. Mm-hmm.
So in our brain, neuron seems like this. So a typical neural network looks like this. This.
Okay. Hmm.
So lot of such neurons connected together.
Ah, okay. Hmm.
So basically, they are trying to mimic our brain.
Hmm.
All these neurons will be connected to each other, and then like there are a lot of layers like this. And finally,
Okay.
you will be so you pass it an image here, and
Hmm.
it will detect what is the object here, what is the object in the image by passing through this whole layers. So neural network is again a whole field. I mean, neural network is one such model. So see, like I told you, like earlier there was this AI, artificial intelligence, all these things. Now
Okay.
machine learning has overtaken AI, basically, overpowered it. Like all those things
Hmm.
which were done through AI, machine learning is easily able to do all those things. So basically that's what I told you. Machine learning is new AI. Similarly, what is the situation of machine learning with AI? Maybe 10
Hmm.
years later, the same situation will be with deep learning and machine learning.
Ah, okay. Okay.
Maybe
Hmm.
10 years later, deep learning, this new, which is based on neural network, this will be able
Hmm.
to do all the applications, and it will be able to, outperform all the other models, whatever they are, and people will be building applications on based on only neural networks. But neural networks,
Okay.
deep learning is still in research. It has not come to
Hmm.
industry yet. I mean, it has come
Okay.
to industry, but just partially.
Okay. But
Yeah.
human diseases also we can identify also.
What?
Human diseases. Let's say I have pain there, here, there, and
Yes,
all.
yes, yes. Lot of things. Lot of things. Deep learning can do lot of things. Through medical images, it can, detect what disease you have. Alzheimer detection. Lot of research people are coming up with in research papers. I saw those research papers daily. I mean, in
Okay.
medical field, in lot of field. I told you, speech analytics, image processing, computer vision field has evolved because of deep learning. I must tell you.
Okay. Okay.
This
Got
field
it.
of computer division, basically image processing, that I mean, deep learning
Ah,
has,
okay.
before deep learning, computer vision was very tough. Now after deep learning, they are able to, mimic how our eyes sees and how our brain detects. They are able to, there is something called as CNN model, convolutional neural network. Those are very popular and those are very efficient model
Okay.
of deep learning
Hmm.
are used these days. But these things are still in research. That's what I am telling you. Because to
Okay. Okay.
do deep learning, first
Hmm.
thing is you require a very specialized hardware. You cannot do deep
Okay.
learning on this laptop where you have 4 GB RAM or 6 GB RAM and some i3 i7 processor. It requires a
Okay.
GPU graphic, GPU card. It requires NVIDIA GPU cards are there. So
Hmm.
to fasten the processing, because in neural network there are lots and lots of computation. It's a very complex model. There are lots of computations. So to do that, it requires a GPU. So those
Hmm.
things you have to purchase, and maybe that is basically, you know. Right now it's not affordable by a common man. So similarly, I told you, that the thing which machine learning was in 1990s, maybe the same situation is of deep learning is now. Maybe 10, 15 years after, what I can see, this deep learning will, maybe come
Yeah.
come in industrials. Okay, so
Okay. That's.
yeah. Now this big data, if you see, this big
Hmm.
data is all about, if you have huge number of data, if you have to process huge data. I am just telling you, suppose if you have to process a huge data, so
Hmm.
like for an example, I will tell you, in 1 second, or if you just take 1 minute of Twitter data, In 1 second,
Hmm.
millions of tweets are coming in.
Right, right.
So how are you going to process such a huge bulk data which is coming? So you have to, put big servers, and you have to, put parallel machines, and then you have to pump all the data, and parallelly you have to process that. So when you have
Yeah.
a huge data and you have to process them parallelly, then this big data comes into picture. You might have heard of Hadoop systems, Spark, these things you might have heard of. So
Yeah.
Hadoop,
MapReduce,
yeah,
HDFS,
MapReduce you might have heard of, HDFS, Hadoop distributed file
Spark,
systems you have.
Scala,
Yeah, yeah,
non-SQL, MongoDB,
yeah,
unstructured data.
yeah. So that is basically big data. Okay.
Oh,
Yeah. So in machine learning, basically, the thing is like this big data handles the volume of huge data, and then machine learning will do its learning and it will give you the result. Then again, big data will send you the result back. So it is like that. For bulk processing, for huge, data processing, big data is combined with, integrated with machine learning to do intelligent tasks, to create intelligent applications. Okay. And data mining is all about how do you get data. Data mining,
how?
no? Data mining is like, suppose you have a web page. How are you
Uh,
scraping data from there? Data mining is all about how do you mine data. Suppose I,
what? Okay, quality, and
what?
data quality. Data should not be null values. This is the
Yes,
best
yes.
best stuff.
Yes,
Okay.
those things comes under data science. That it should have no null values, or it should, I mean, data science is all about the statistics, like to visualize data, like how many calls were coming on Monday, how many data points are there generated in on Sundays, or whatever statistics, basically, like how
Hmm.
many people came for dinner in the restaurant on Sunday, and what was the statistics on Monday. So this, or you can say data visualization, to get the insight of data, how the data is looking. So basically the visualization part, those things come under data science. Data mining,
Okay.
I will give you the specific example of data mining.
Hmm.
Suppose this internet, suppose you went to
Okay.
suppose a website, suppose uh, just take any example, like I will show you a website, Voxforge.
Sorry.
Okay. Now,
Hmm.
so the basically this is a website. Okay, Voxforge, which keeps lot of audios. It keeps lot of audios. Okay.
Sorry.
So suppose I have this audio. Hmm. Now you can see how many files are there here. This many files are there, right? Now,
Yeah.
yeah. Now data mining is with this link. I give you this link URL. Okay.
Hmm.
Now with this URL, can you make a software? Can you make a simple web crawler which can go to this link and download all these links?
Okay.
So basically data mining is about the scrapping the data. How do you see, when data is actually present, it will present in some unstructured format on some website, on somewhere it will be there, right?
Yeah.
So how do you actually collect them? So the collection is called data mining.
Okay.
Okay. So this web scrapping is one of the examples. Say suppose you go to news, Google News. Okay.
Okay. Hmm.
This Google News is there, right? Now if you see, This Google News. Now this Google News is an aggregator site. If you see this particular article, you see it is from ClickBuzz.
Okay.
This particular website, this particular site is from NDTP. I mean NDTV. This article is from
Okay.
Indian Express. So that's what I am telling. If you see these articles, if you go on this article, this will
Okay.
take you to Times of India website. But here it is Google News. So basically what Google News has done, Google News has crawled over all these media houses website. It has taken the
Okay.
all the articles which were there, it has taken them and it has linked it here in this thing.
Okay. Okay, Abhijit, what you type it in the Google? I mean headlines. Can you please
I
what
tell you
you
news. I mean it's Google News actually.
okay. Okay. Okay, got it. Good news.
There is Yahoo News, Rediff News. There are a lot of news actually. So, those
Got
so these sites basically do
it.
what they will crawl over the websites of other media houses and they will scrap the articles and they will put it here. Links it will put it here and see how it has categorized the articles like India, world, technology. See technology, Samsung, all these things are entertainment, sports, science.
Okay.
So all see they
Okay.
have, and this is top story. So they have. So do you think that this Google News is maintained by some people in Google?
No, no.
In Google,
No.
some person is sitting over there and who is doing all this categorization? No, it's totally a software.
Yeah. Okay.
It is totally a software. And
Hmm.
so that's what I'm saying. Like these things are now done by machine learning these days. Okay.
Okay.
So that is big data, and this is data mining and data science. I told you it's all about the statistics. What is the mean value of this? What is the average value? What is the mode of this? Mean, median mode. What is the statistics? How many calls came? This kind of data. Basically, analyzing your data. Data
Okay.
analysis is called data science. But data
Okay.
science do
Got
not
it.
include any learning. When it comes to
Yeah.
learning, when it comes to getting intelligence out of it, it is machine learning. Okay.
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 Hmm.
So this actually I wanted to give you a whole overview of machine learning. I mean, from this
Okay.
slide, I have recorded sessions, okay, which will
Hmm.
take you through all these slides of this introduction part, and
Okay.
then the subsequent then the subsequent sessions on
Hmm.
these uh, on these algorithms, whatever algorithms are
Yeah.
there in introduction, this for every session I have maybe like
Hmm.
1 hour session or 1.5 hour session, although those sessions
Okay.
are like the real recorded sessions which I provide training to some people. Okay, so
Okay.
that you may find it's not a that cleaned, and it's not a professional video, but yeah, whatever session, like I have recorded this session also.
Okay.